Hi everyone, Sarah here, one of your clinical prosthetists and manager of technical support and global clinical communications at Freedom Innovations. This webinar replay is going to be the Kinnex 2.0, which is presented by another one of our clinical prosthetists, Matthew Nelson. For CEUs, at the end of the course, you will see a web link and you must pass that quiz with 80% or more to get your CEUs. For state licensure and BOC, we will email you a completion certificate that you can then submit to the board. For CEUs that are available whenever you are, visit our website, freedom-innovations.com/P&O data for a variety of free online CEUs that are available whenever you are. Thanks again for your interest in our webinar.
Hello, everyone, and welcome to our first Freedom Live webinar series. We'll give everybody another 30 seconds or so to dial in here, and then we'll get started. So thank all of you for joining us today. All right, so we will kick this off in style. So once again, thank you and welcome all of you to our Freedom Live webinar series. The first of four, as you likely saw in our general introduction, both on social media, via email, and hopefully via your local rep as well. It's interesting, we've been brainstorming a bit, right, in terms of this bizarre time, in terms of how can we add value, how can we help all of you as we all kind of just navigate through, obviously, the COVID-19 situation. And I kind of struggled with how to introduce this section. And so this is kind of where I think we'll go. First of all, my name is Eric Ferris. I'm the head of marketing here at Freedom. And we were kind of brainstorming as a commercial team, again, how do we add and how can we help you guys in this particular period? And I think the message that I really want to send prior to turning it over to Matthew for the course is that really Freedom is open for business. I think this is, it sounds bizarre to say it, but we've really done a lot of preemptive and proactive measures to make sure that we really are able to match the level of service to the best of our ability at this time, right, that you've come to expect from Freedom over the years. So we have all of our customer-facing functions. So that includes, obviously, sales, customer service, clinical services, marketing when needed. We've provided all of them with remote access. And so if you need our help, please let us know, and we will do whatever we can to help you out. We've also implemented some social distancing, work sequencing things within our manufacturing plant so that we can continue to manufacture throughout this time, obviously in accordance with CDC guidelines. So we really feel that we've positioned ourselves well, and if you need something, then please let us know. And again, we will do everything we can to help you through this time. So one of the issues and one of the ideas that came back when we asked about adding value was around CEUs and accreditation. A lot of people have seen their regional meetings canceled. A lot of people have asked about CEUs. So we've started this program we call the Freedom Live webinar series. I call it the Freedom Hour. Because it's every Thursday at 11 a.m. Pacific, 2 p.m. Eastern, we will offer a CEU course. Each course will be 1.25 CEUs. And over the next 4 weeks, we'll have a variety of different topics. Today, it's about Kinect, our new microprocessor controlled foot, which we think is an industry-leading technology. Next week, again, 11 a.m. Pacific, 2 p.m. Eastern, we will talk about our ankle portfolio, including obviously Kinect, obviously our Kintera for K3 amputees, and then our new control for K2. The next week, that third week, 11 a.m. Pacific, 2 p.m. Eastern, Freedom Hour will be the plie. We have a programming methodology that we call the kind of 5 minutes or less that allows you to put more time around customization of that device and of that knee versus kind of getting someone up and walking. So we think it's a very efficient way to program that knee. And the final one that we have scheduled so far, the fourth week, again, 11 a.m. Pacific, 2 p.m. Eastern will be around our new elevated vacuum system called the IQ. And so we really think these will be valuable. If you have any ideas in terms of other information you'd like, let us know. I'd love to continue the Freedom Hour as we move forward. Again, 11 a.m. Pacific, 2 p.m. Eastern every Thursday. And any topics that you think would be valuable to you or your community, please let us know. So with that, I'm going to turn it over to our host, Mr. Matthew Nelson, who has really been in the field for a number of years. And actually managed a clinic in Atlanta for about 20 years, started with Freedom in 2015, and I think has been really instrumental in kind of merging real-world clinical needs and bringing that perspective into the company and really kind of allowing us to customize our programs and streamline our products in a way that really reflects, I think, real-world clinical need. So Matthew, with that, I'll turn it over to you and we can start our course. Thank you.
Thanks, Eric. Appreciate it. So I am going to kick things off here. One treat for you guys is I'm going to use a webcam so you can see me. I will say that this is the first time I've worn a collared shirt in about 2 weeks. So I got dressed up just for you guys. But I do appreciate you joining today. Looks like we have about 88 attendees currently. I know you guys, this is a weird time for everybody. You guys need credits. And so our goal today is to provide credits and also to give you information that I think is important for the Kinect 2.0. So I'll go ahead and get started. There's about 60 slides. We have 2 hours blocked out for this webinar. I'm guessing it's going to take me maybe an hour and 15 minutes at the most. So just stay tuned. And again, Kinect 2.0 overview is the course today. And the Kinect 1.0 came out, and it was soon after I started at Freedom. It was 2015. I remember in San Antonio, we did a release party at the FAAOP meeting in San Antonio, and it's evolved a lot since then. We had some things that we had to change, and it was re-released a few months ago. So I'm excited to talk about what we've done that's different between 1.0 and 2.0. So a couple of housekeeping things I want to bring up. If you guys, if you had problems logging on, or if any future webinars you have problems logging on, what we have found is if you restart your computer, typically it will fix it. There are obviously a ton of go-to meetings and Zoom meetings happening currently. So, you know, I think the systems get bogged down, but again, restart your computer. Second bullet here is, you know, this current situation with the COVID-19, it's strange. I'm working in my home office. I typically am on the road, traveling a couple nights a week, doing courses. So we've all had to kind of readjust what we're doing, and it's, you know, you just got to make the best of the situation, and that's what we're trying to do for you guys, provide credits, also have some interaction between us and the field as well. These webinars are ABC approved. I contacted ABC. There are typically limitations on how many credits we can give for, or how often you can do a webinar, but they gave us approval and are going to provide some leniency during these confusing times. In addition to these webinars that we're doing that Eric mentioned, we also have some Fit Online courses. So you have an opportunity to get 10 additional CEUs for free, and we can provide that information to you, but it's just online. You can take it as you need the credits, but again, 10 additional free CEUs. Also, we can do, you know, again, I mentioned that you know, part of my job is to travel and do courses. We've been given permission by ABC to do webinars individually. So if your clinic has a need for credits, then certainly we can do a one-off, and it doesn't have to be a webinar series. So during the presentation, there'll be some videos that I'm going to do, and I'm going to kind of toggle back and forth between the PowerPoint and the video, so you guys might see a little glitch in the system, and then I will actually also be muted, and then I'll come back on. So just know there might be a little bit glitchy as I do that. The other thing is the questions you can go into. I'm not looking at what, I can't see what you guys are seeing, but you can add, or you can ask questions throughout the presentation. Everybody is muted except the panelists, but you can ask questions. Just type in your questions, and then at the end we'll address your questions for you. Okay, so the objectives for the course, and again, this is the Kinect 2.0 overview. We do have a certification course as well, but this is the hour-long course, and you'll get 1.25 CEUs for this course. We'll talk about what's new with Kinect 2.0 as compared to the 1.0. We'll talk about features and benefits. We will also talk about coding and reimbursement. I am actually, part of my job at Freedom is I'm the coding and reimbursement manager. So I've gained a lot of knowledge in this part of my job over the past 5 years, and certainly can help you guys with the coding and reimbursement aspect. And then the last thing we'll do is we'll go over how it works. So the Kinect 2.0, our goal in developing this product was design something for real life. So really, all the things that people need to do on an everyday basis, really to design something that will help them function. And a few things that we did that we focused on is making sure that they had a reaction from the ankle on their first step, and so it doesn't require the ankle to process 5 or 10 steps. On the first step, it's ready to go. The second thing, it's something called IP67, which stands for International Protection Rating. The 6 stands for dust protection, and the 7 stands for water protection. So it is a submersible product, similar to Plie and IQ. So you can get it wet. You can submerge it 1 meter for 30 minutes. And another big thing is you can, again, from an ADL standpoint, a patient can go barefoot up to a 2-inch heel. Essentially what you do is you calibrate the ankle to that particular shoe, and I'll show you we'll talk about how to do that later. And then the last thing is and I'll talk about the foot module that's attached to the ankle, but it's a Pacifica energy storing 5981 style foot that does return and store energy throughout the day. So what's new with Kinect 2.0? I like to focus really on the kind of high level things that we did. We had with 1.0, admittedly, we had some hydraulic issues. Didn't happen on every ankle, but there were ankles that had leakage, and when there's leakage in the hydraulic cylinder, you basically lose hydraulic resistance, and so the patient, they can't function well. So we spent a lot of time, trying to figure out exactly what we needed to fix, and we did that. So we fixed the seals and the cylinder to where it doesn't leak like it did before. The other thing we did is the testing that we did was much more robust than it was for Kinect 1.0. We kind of learned our lesson. We did this 3-year internal testing, and then we also tested 30 users in the field, and I tested like 10 people on my own, and just kind of put the product through the ringer and make sure that we had fixed the hydraulic cylinder. And then also we sent the product to a third party and let them validate the design as well. Last thing we did is during the process of testing the cylinder, we also improved the user experience. A couple of things we did, we fine-tuned some things about the application. We also took away the manual lock on the back of the ankle that was problematic for some people with dexterity issues. And so again, while we were working on the hydraulic cylinder, we also improved the user experience. Features and benefits. All right, so I'm going to show you a video.
I'm sorry, before you jump into that, guys, I'm seeing a couple people who are saying they're having some audio issues. I'm going to send out a note. Please ensure your speakers are on. I'm assuming if you can't hear that, you can't hear that. But if you're having questions or issues, please contact us through the chat button. It's located at the bottom right-hand corner of your screen. Thanks.
Okay. All right, so I'm going to toggle away from the PowerPoint and get to the first video. And I will be muted when I show this video, but essentially, this is one of actually it's a few of our patient models, and you'll see them walking around on different terrains, but just, again, I'll talk about the range of motion a little bit later, but there's 30 degrees of total range of motion, 20 plantar and 10 dorsi. So just try to appreciate that when I show you the video here. Okay, should be back up to the PowerPoint. So again, the video was basically showing you guys how the ankle performs on uneven terrain. All right, so I want to go through some product specs before I talk more about the features and benefits. So the L code is L5973, which is a microprocessor ankle and foot system to include power source. This code has been around since 2010. Additionally, this code is part of the Medicare pre-authorization that will start in 4 states in May, and then for the rest of the country in October. So I've got my opinion about the authorization with Medicare. I know that I've heard from several people in the field, but I think it's probably a good thing. But again, this code will be a part of that pre-auth system. The sizing currently is 24 to 30 centimeters for the Kinnex, 24 to 28 offering for sandal toe. Max weight rating is 275 pounds. I get questions about that weight rating. If somebody's 280 pounds, do you weigh them with or without the prosthesis? I would say if they're close, it's probably worth doing a trial just to see how they do with the foot. Again, I mentioned the heel height adjustability is from 0 to 2 inches. And then as well, I mentioned the 10 degrees of dorsiflexion, 20 degrees of plantar flexion for a total of 30 degrees. We actually did additionally measure the carbon fiber deflection just because we get that question, and we measured the deflection of the carbon at 17 degrees. By no means are you going to get 47 degrees of deflection when you're walking, but just know that you're getting hydraulics and carbon fiber deflection when you're using the foot. The build height, actually the weight of the foot is 3.8 pounds. Build height is 7.3 inches. Backing up really quickly to the weight, my opinion, when I teach these courses on Kinect in person and I do trials, I address the weight, from the jump. I just like to talk about, the fact that the technology is heavy, just like the other microprocessor ankles on the market. I would just encourage you to let your patients do a trial. I've tried somebody about a month and a half ago that had a pin system, a very short limb, came in actually to the office wearing his foot without a foot shell because he wanted to be as lightweight as possible. So, but the guy was willing to trial it, and initially he put it on. Again, he had a pin system. We put a sleeve over top of the socket to help weight. And initially, he commented that it was pretty heavy. I will tell you that after like 15 minutes, I asked him about the weight and he'd forgotten about it. So I would say don't rule people out, just at least give them a chance to try it. All right, so then there are occasions. There's a Gait Lab app, which is for the CP, and then there's a Kinect app, which is for the patient. And we'll talk about those specifically, but basically the Gait Lab, actually the Kinect app is kind of a stripped down version of the Gait Lab app. So again, designed for real life. I mentioned this before. Just want to talk briefly about the pictures you see here. So there's, our corporate office is in Irvine, California. So a lot of what you're going to see is our beach scenes. Obviously, the top right-hand corner, this individual is not from California. I think she lives in the Midwest, but she's raking leaves. But the point being, you can do a little bit of everything. The guy that's on the beach is, his foot's plantar flex to kneel to take pictures. We've got a gentleman in the device is IP67. We've got a patient walking on uneven terrain, and then again we've got this young lady walking or raking leaves. So again, designed for real life. This rapid response valve technology, essentially what it is, there's a valve inside the hydraulic cylinder that opens, or actually it's an open default system, so it closes based on how you program the ankle. But just know that it's extremely rapid. It basically in 5 milliseconds, it's calculating what needs to take place. It is a sensor controlled ankle movement. So it's got 3 sensors on it that we'll talk about. And again, we talked about the range of motion, 30 degrees. And then it has 2 locking mechanisms. So it has a dynamic lock, which is what happens. It's a locking mechanism that happens when the patient is standing still. And then also when they're walking, the valve actually shuts inside the hydraulic cylinder, and we call that the dynamic lock. The manual lock is just like it sounds. The patient is able to manually lock the ankle in any position between the 30 degrees of range of motion. And then again, there are 2 apps, and the patient can either make adjustments with the app or use the keypad on the front of the ankle. And then we talked about the IP67 rating as well. So So key clinical benefits, couple things. Again, this is the young lady that's raking leaves. This other picture is a patient model that we use a lot. His name is Ramin. And this is one of those things that, it's probably not a big deal. It's maybe not something you would justify or use as justification to insurance, but you know, he's kind of a cool dude. You know, he's leaned up against the wall with this nice shiny beard, and he's always well groomed, but he likes to, you know, hang out and lean up against the wall, and the foot plantar flexes. And he just has talked about how big of a deal that is. The fact that that foot will plantar flex to, you know, up to 20 degrees, and he can hang out and not have that toe sticking up. But that's one of those clinical benefits that we probably don't think about. So ramp ascent and descent. So again, this is really referring to the range of motion, the fact that when you go up the hill, you can pre-position the ankle and the dorsiflexion to make it easier to ascend, and then going down, obviously, it's the plantar flexion that helps. Uneven terrain ambulation. So again, that's coronal and sagittal motion. So in the coronal plane, you're talking about the side-to-side motion provided by the Pacifica foot module, and then in the sagittal plane, you're talking about dorsiflexion and plantar flexion. Ascent and descent, pretty similar concept to the ramp. Again, you can to go up your toe, and then also to prevent like a push to extension. So it definitely makes it easier going up steps, and then descending is similar to going down ramps. So chair relax and exit. We have a video on this. This is another really big thing that Ramin has talked about our patient model, that, you know, the fact that he can, when he sits down, when you load the heel slightly, the foot will plantar flex, and it basically, you know, puts less pressure on the limb. And then when he goes to stand, which we do a lot every day, over 50 times a day, you can bend your knee, and the foot will plantar, actually dorsiflex up to 10 degrees. And the fact that you can get it underneath you to stand up is a lot more energy efficient, and it's a big deal. And again, we talked about the weight, the IP67 rating. All right, so another video. So again, this actually is just, I keep mentioning Ramin, but he's kind of one of our stars patient models, but he is a bilateral below knee amputee, wears elevated vacuum, and the Kinnex 2.0 ankles. And this is a video of him just going up and down slopes and ramps. So I'm going to toggle to the video real quick here. Okay, should be back up. All right, so just a couple of things to point out about the video is most people, and I honestly, when I first started working with Kinect, it was easy for me to understand the going down slopes. What you have to do is you have to pre-position the ankle into that dorsiflex position, which is a hard stop at 10 degrees. And I don't know if you guys were watching the video, hopefully you were. When Ramin is going up the slope, you know, a steep slope, it's so much easier to go up because the foot is dorsiflex and he clears his toe, but then also there's less pushback on his knee. When you teach somebody to do that versus not show them how to do it, it makes a huge difference, okay? All right, so we're gonna talk a little bit about coding and reimbursement. So again, the billing code is L5973, microprocessor control ankle, endoskeletal, dorsiflexion and plantar flexion control. It includes the power source. You really additional codes for the foot add a 81, add a 86 for the really this is your base code. You can't add a charger. You can bill a replacement charger once the charger's out of warranty and you need a new one. But essentially, this is the billing code that you would use for the Kinects. The average Medicare reimbursement is $18,094 across all 50 states. So just on average, that's what you're going to get. That's 100% reimbursement. Which what I would say about this, it's a lot of money, right? So I'm pretty passionate about teaching the course. I'm just trying to at least so you can show your patients so we can have the best outcomes possibly, because you're billing a lot of money, right? Again, the code has been out since 2010, and it is for K3 only, which I'm guessing everybody on the call knows is variable cadence. We'll talk about, within that category, the ideal patient. Additionally, we do have a reimbursement packet that you guys, I will say from point, all my connections at Medicare, whether it's CGS or PDAC, in my conversations about this new authorization process, they all refer to the lower extremity checklist, which is a Medicare document that really is really straightforward. I was told that this authorization process, nothing's going to change. I mean, there's no new requirements. So really, if you just focus on that checklist, and you can Google it and find it pretty easily, that's what you need to justify to Medicare that your patient needs an L5973. But what we have for you guys is, if you look on the website, there's a reimbursement packet. If you go under, I think the tab is prosthetist and then coding and reimbursement, there's an LMN, letter medical necessity. There's a summary of benefits. There's a documentation checklist. This is only available, the $59.99 coding is only available on request to you. I would not mess with this unless you're trying to bill work comp. Is probably the only payer I can see. Maybe some private payers might pay for 99 codes, but I would probably stay away from this. We also have information on outcome measures. And then also, if you guys have, as the insurance company that is experimental or investigational, I would, if they're just saying it's experimental, but it's not excluded, then I think it's worth fighting. If it's excluded from the plan, it's probably not worth fighting. But we have all this documentation on our website. All right, so how does Kinect work? So, just going over the anatomy of the ankle itself, I think it's important to know kind of what you're fitting here, obviously. But number one is the ankle. Number two is that basically, I mentioned this before, but it's a modified Pacifica. The Pacifica foot has been around for, it's probably been, over 10 years, but it does have a split keel and heel section for that coronal motion. Number three is there's 3 buttons on this keypad. The top button is your battery button to check your battery status. The middle button is your change shoe button or your manual lock button that we'll talk about. And then the third button on the bottom is the Bluetooth, and 4 is the charging port. All right, so I do want to just talk briefly about alignment because it's super duper important. A lot of people at Freedom, we recommend actually what we call the anterior dome of the pyramid. So it's really where the titanium pyramid meets the foot. So that's really where we like to see it. I have found that so our range is 0 mark. I found that most people tend to do best through the charging port. So again, I carry a laser with me when I travel. I think the user experience is a lot better if you focus on getting this more towards this line here. If not, then what happens is that they basically don't have enough heel, and you're having to ramp up the plantar flexion resistance. So just really make sure you focus on the alignment. And then especially for larger patients, or if you have really strong heel walkers, you really want to be more towards the center of the charging port when you align the foot. All right, so I mentioned before, so the Kinect has 3 sensors. It has a load sensor that detects how much connects, and then it has a torque sensor, which is basically your forward and backward rotation from a sagittal plane standpoint. And that has an angle sensor, which basically the sensor is telling the microprocessor what angle the foot is, or the ankle's in. So 3 sensors. and then it has this valve. So it only has one valve, and essentially we call it the rapid response valve technology. Essentially every 5 seconds, I think I mentioned this before, the Kinect microprocessor is sampling data from sensors and responds by adjusting the valve position. So I'm hoping you guys would understand that if this valve was wide open, essentially this is partially closed, but if it was wide open, there's little or no resistance. Whereas if the valve is shut, that means it's the either the manual lock has been applied or the dynamic lock has happened during standing or walking. So again, the more you shut the valve based on how you control or you set up the ankle, the more resistance you have. But so anyways, the diameter, the amount of resistance. Okay, so indications, I had mentioned this before. So again, we're talking about this K3 level ambulator. We tend to, at least I'm not sure about other manufacturers, but Freedom, we tend to divide K3 into low, moderate, and high. So and really what that means to me, like your low K3 is more of like your patient maybe that occasionally uses a cane to walk, but it's a pretty good walker. Your moderate is really your good everyday K3 ambulator that has the potential for variable cadence and sometimes does it. And then your high K3 is really your more active patient that might verge onto a K4. But the indications for Kinect is this low to moderate. From a justification standpoint to insurance or to Medicare or private payers or whatever, it really needs to be somebody that incurs or faces uneven terrain on a daily basis. And then, it could help with excessive socket pain and discomfort. If somebody has a chronic distal tibial issue, potentially having this plantar flexion provided by the ankle will help with this excessive socket pain, and also when they're sitting. And then if they, would like to go barefoot or wear up to a 2-inch heel, then obviously you can do that with the Kinect as well. Contraindications, the only thing I will say about, for sure, this type of patient, if this is the only thing they have access to is one prosthesis and one foot, then probably not. The Kinect is not meant for basketball. I will say that, Ramin, our patient model, he has access to, more than one prosthesis, more than one foot. So his everyday foot is a Kinect and it keeps up with him. But for his activities like running, he would wear a different prosthesis with a running foot. So it is contraindicated if this is the only thing that they have access to. But if they can get more than one prosthesis, let's just, if they're a vet or if they're work comp, then certainly it's worth trying. Obviously, if they have a long residual limb, because the build height would be restrictive. And then again, if they want to run and jump, then it's probably not a good choice. And then the only thing I'll say about this fourth bullet is, my rule of thumb is if somebody walked in and they had a smartphone, then they were probably a decent microprocessor controlled candidate. If they came into the office and they had a beeper or a flip phone, then probably not the best candidate. But what I will say is the only thing you actually have to do with Kinect is you have to charge it. The other, whether it's the keypad or the smartphone, they really don't have to do anything. They could just charge it and not, especially if you're thinking about maybe a dysvascular diabetic patient that they really just focus on one pair of shoes, and you kind of set the foot up for that shoe. They're not changing shoes. Again, they could get by with it. I would suggest that kind of patient, letting us do a trial with you to let the patient see it. All right, so the Gait Lab app is the app for the prosthetist. Again, it allows the prosthetist to set up, the calibrate, and to adjust the Kinects. It does have a cadence reporting feature that I'll show you later. It looks similar to the Plie cadence report, but it shows you walking data from 2 weeks prior, which I think is really valuable. And then it is iOS and Android compatible. Most people seem to have iPhones or iPads, and this is what I use, but it is Android compatible as well. All right, so when you open up the app and you've connected to the app, well, actually before you connect to the ankle, but this is what you'll see. You'll see Connect, which is obviously going to connect you to the ankle, then Help, About, and Demo. The nice thing about the demo mode is you can actually kind of go through the whole process of programming with an ankle without the ankle actually being in front of you. So if you guys downloaded this app, you would go to your app store and you would search for Freedom Gait Lab, and then it would allow you to download the latest version. But again, you can go through the demo mode. All right, so the Kinect has 2 Bluetooth radios. There's a Bluetooth high energy, which is what you need to connect to the Gait Lab app, and there's a Bluetooth low energy, which allows connection to the Kinect app, and that antenna is always on. The high energy is not on all the time, because if it was, it would drain the battery. So basically, when you're trying to connect to the ankle with your app, you have to turn the Bluetooth radio on, and I'll show you how to do that. But basically, you press the Bluetooth button, which is the bottom button, until it starts flashing. So you can find the serial number of the ankle if you pull up the top cap of the Kinect unit, and you won't break it. Just serial number, and so when you're searching for an ankle, that's where you can verify you're connecting to the right ankle. And it does take time. Basically, what I tell people, if your device has not shaken hands with that ankle before, and they've never been paired to each other, it usually takes a little bit longer than when they have connected before. So it can take up to 90 seconds. So there is an authorization code that comes with a new ankle. It's a card that's inside the box, and basically what it does is it's a code that each code is individual to the ankle serial number, but you're authorizing your device, not the ankle. So once your device, your iPhone, your iPad, whatever, has been authorized once, it doesn't have to be authorized again. So again, you only have to put the code in once for your device. What I will say that people get in trouble is if they've connected before and they get a new phone, and then the patient comes back in, they're trying to connect to the Kinects that they fit a year ago and they can't connect. I would suggest that you just save that serial number or that authorization code in the patient's file. If for some reason you can't find it, you can contact clinical customer service from Freedom, and we can provide that number for you. Okay. And basically what that code does is it just prevents unauthorized use of the Gait Lab. For instance, the patient having access to all the different controls that you guys have access to. All right, so product pairing, I just wanted to show this screen really quickly as you go through the connection of the Kinects. The one thing, it's kind of funny that more often than not, when this screen pops up, when you've pulled up the serial number and you've clicked on Kinect and it finds the serial number, the one thing that you have to do, and this prevents people from connecting to somebody walking down the street with a Kinect, so you have to press the Bluetooth button on the front of the Kinects. But it's funny because people will skip past this and then you can't connect. But just the bottom line is just the directions in the app are perfect. They tell you exactly what you need to do. You just press the button and it pairs the product. All right, so then you get to the full setup, and I'll just kind of speed through here, but basically the full setup. This actually has changed a little bit. When you first connect, this will not be grayed out, so you'll have access to full setup or bench alignment. The rest of the stuff will be grayed out until you at least do the full setup or align it. So it has changed slightly since the first or the last version. But if you'll go on the App Store, it'll download the newest version if you don't have it already. Okay. And then going through the full setup. So again, this app is super duper easy. I kind of joke that it's prosthesis proof. It really is. It's very simple to go through. It tells you exactly where to look. You don't necessarily need like a manual. It tells you on the phone screen what to do. But you click begin, and it guides you through the whole setup process. The one thing that I will say, when and if you guys fit a Kinect is when you go through the setup process, it's going to lock out the ankle at one point during the setup process. You need to make sure that you have a 3/8 of an inch heel height shoe. If you think you do, just verify. And we actually have the new version of the app kind of tells you kind of what to look for. You want to make sure the pyramid of the foot or the ankle is parallel to the bench. And if it's not, then just wedge the heel or the forefoot of the shoe. Of the prosthetic foot, just to make sure it's level when you do the initial program. And we'll go through sensor calibration and then the different resistance adjustments. And then we'll have some demo modes as well. All right, so first step is you calibrate the sensor. So again, we mentioned that the Kinect has a load sensor, a torque sensor, and an angle sensor. So really what we're doing is just, and again, I can't overemphasize the ease of the program or the app. It tells you, have the patient unload or unweight the sensor. You click ready. Next screen is you have the patient load the Kinect unit, and you click ready, and then you have them start walking, and you're calibrating the torque sensor, and you click ready. It's really super easy. And then you go, this is really kind of the meat of the program in terms of what you're doing to the ankle. So again, you have this microprocessor ankle. You know, I say that the Kinect is kind of the Kinterra on steroids. The Kinterra is a foot that it may be either a number 1 or number 2 selling foot at Freedom, but we sell a lot of Kinterra foot and ankle systems because they're a great foot, or it's a great foot. But the Kinect it does a lot more. And what it does is it gives you more range of motion, and then you can really, similar to Kinterra, you do have a heel and an ankle adjustment, but you just don't have the range of adjustability. And then you also have a toe adjustment that we'll talk about. But this is really this is kind of the screen that really makes your patient feel what this thing can do. These are the factory default settings. So you have your heel, which is your plantar flexion, you have your ankle, which is your dorsiflexion, and then you have your toe setting. And we'll talk about these 3 things. So the plantar flexion is pretty easy to see. Your patient's walking, if they've never walked with an ankle before, it may feel like they're kind of slapping their foot. So what you would do is if your default is 80, you're going to turn that up. So the higher the number, the more resistance. And in essence, what you're doing is you're shutting that valve more and more as you take that number higher. So again, there's just one valve, pretty simple. You turn the number up, the valve closes more. I will say that if you get to 100, which means you've maxed it out, is probably not ideal. And so I would just, if you get to 100 from a resistance standpoint, just go back to prosthetics 101. At that point, you're maybe changing alignment to give the person more heel. So you shift the socket forward. You might add heel bumpers. If you're doing a trial, you might add a higher category foot, possibly, but there are a lot of different things that you can do. I find that when you have that alignment, that sagittal alignment dialed in, and you verify the heel height, then you typically are not going to be at 100, but you want a little bit of room. You don't want to deliver something at 100 because then you can't go up any further. Okay, so again, best results are don't start at 100. Next one is ankle, which is dorsiflexion resistance. This is a little bit harder to see, I think, but essentially what it is when the foot gets the foot flat as the ankle is dorsiflexing with the foot on the ground during mid stance is when they're feeling this resistance. And so it's harder to see. A lot of people say, hey, 65 feels pretty good. What I like to do is I'll go up to 85 and just let them tell me how that felt. And then I might go down to 45. And, going up to 66 is not going to do much, but really, really give them a chance to understand what it feels like. And then the last setting, which is called the dorsiflexion stop. So again, this is where, now I will say this, if you guys are able, if you're looking at my screen, this center red line is this calibrated angle that when you had the patient stand and you went through the first part of the program, you're going to establish this red line in center, okay? And so when the patient's walking, as they're getting the late stance, before they get the heel off and toe off, this is where the valve actually shuts and it goes from hydraulics to carbon fiber deflection, okay? So this is the 0 line. So again, patient's walking, the valve's open until it gets to this point, the valve shuts, okay? So what you can do with that is you can adjust when that valve shuts. So you can go up, which is positive, or you can go down, which is negative. So if you go up, let me go back, sorry. If you go up, which is positive, you're going to give the patient more toe. So essentially what you're doing is you're getting into this area here where you're stopping it short of that 0 line. So the valve's going to shut sooner and they're going to feel like they have more toe. Sometimes it's hard to explain this to a patient. So again, what I like to do is just kind of move it up and down and let the patient feel it and then let them tell you kind of what they think. The other thing I'll mention about this is as you go up 10 points up or 10 points down, that's 3 degrees total. So each degree is about 3.33 points. So my point being is if you start at 0 and you go to 0.1, 0.2, they're not going to feel anything. I would go at least 3 points so you get to 1 degree so they can tell you, okay? But again, super easy. So a heel, ankle, and toe. All right, so I just talked about this dynamic lock. So the dynamic lock, again, is where it's kind of that initial calibrated line that establishes this vertical line position. And this is when the valve shuts during level ground walking, okay? But what has to happen for it to actually stop or the valve to shut is they have to get to that angle. So if they're in plantar flexion, so if they're on this side of gait and it's plantar flexed, it won't lock. So they get to that angle, and that's when it has an opportunity to lock. The other thing is that the user has to have 20% of their body weight on the ankle for it to lock. So again, they have to get to that angle, they have to load it 20%, and then it locks. This is something you need to explain to your patients. I mean, if they understand, hey, this is what it takes to make it lock, it's going to work better. Okay, so dynamic lock. So taking this further, so just from a going up inclines or the chair exit mode. So as long as you are below 20%, you can get to that full dorsiflex position. We call it the hard stop. So this is beneficial before a patient goes up an incline. They could pre-position the ankle at that 10 degrees hard stop because they haven't, if they lightly load the toe below 20%, they get to that hard stop. It's easy to go up ramps and stairs. Additionally, this chair exit, if they pull the foot behind them, as long as they're below 20% load, they can get to that hard stop for going or for standing up. So it's extremely beneficial that you guys understand this so then you can tell your patients. Okay, so again, it locks out in dorsiflexion. So next video, I need a break, need a drink, is the relaxed chair exit mode. So this again this is one of those activities, honestly, when you talk to patients and they verbalize how much easier it is, when or actually in the relaxed mode, how much more comfortable it is on their limb with the foot plantar flexes, but then the chair exit mode, it's just not one of those things that you necessarily think about, or at least I don't, but make sure you have your patients try this. So I'm gonna toggle over to the video here and I will be muted. Okay, should be back on. That is some rockin' music for relaxed mode, huh? I like that video, but again, it's again, I think it's one of those things it's hard to appreciate, if you're not an amputee, what the patient's feeling. So just definitely let them try it and teach them how to do that. All right, so enhanced stability. So this is something that we recommend for bilateral amputees, such as Ramin. It improves stability on inclines, and basically it's a toggle switch within the program. As you go through the program, it basically will say enhanced stability. You can either engage it or disengage it. Essentially what it is so with the normal locking mechanism that you get to that dorsiflexion stop angle and that 20% load, right? We talked about this. Once you load it, it locks. It locks into dorsiflexion, but not plantar flexion. So again, they can, the amputee can rest on that stop, but the foot will still plantar flex. The benefit is if they're sitting and they pre-position, they bend their knee and they pre-position the ankle at 10 degrees to stand. As they're standing, they need to have the ability to extend their knee, which actually will plantar flex the foot, if you can imagine that. So with the unilateral, you don't want to engage the enhanced stability, because what the enhanced stability does is it locks it in both directions. And the reason why we have to do that for bilaterals is, not only on flat ground, it kind of keeps them from drifting around, you lock it in both directions, but also on an incline if they're facing up. What we found is if we only locked it in dorsiflexion, not plantar flexion, then they would fall backwards. So again, I would recommend enabling enhanced stability for bilaterals, not necessarily for unilateral. You could try for a bilateral, both engage in the enhanced stability. All right, and so this is what it is. So again, just to rehash what I just said. So you have this dorsiflexion stop angle that you have to get to 10-degree hard stop. And with a standard setting without enhanced stability, it locks into dorsiflexion. With enhanced stability engaged, it locks plantar flexion and dorsiflexion. Okay, so pretty easy concept to understand, but again, I would skip past it if you're seeing a unilateral. If you're seeing a bilateral, let them try it. All right, so we have some demonstration modes that are, this is part of the full setup when you go through the program or the app. The first one is low battery, second one is dead battery, and the third one is manual lock. You just want to kind of show your patients what these feel like. In this low battery mode or demonstration, it's a little bit different than Kinect's. You would pull up the manual lock or mechanical lock is what we call it on the back of the ankle. It would lock it. What we found is that mechanical lock was problematic for people that had dexterity issues, and then also it actually caused some of the issues we have with the hydraulic cylinder. So now what we have is when you get to, again, this is just a demo mode, but when you get to 20% battery life, and you can check your battery level on your app. But also what will happen is the light on the keypad, the battery button, which is on the top, it'll flash red, and then also you'll have this haptic response, so the ankle will kind of vibrate. So it'll tell, if you do have a dysvascular patient that can't feel the vibration, it's got kind of this rumble strip feel when they're walking. So you have this haptic response, and you have this feeling that when they're walking, it's kind of gritty. But then you also have the red light. So there's three things that really tell the patient that the battery is at 20% or below. I will tell you that if you get to 20%, you still have like 3 or 4 hours left of battery left. And so it's not the worst thing in the world. It's just telling you, hey, you got 20% left. I will tell you also that most people should get a couple days usage out of the Kinects. If you just tell your patient to charge it nightly, they should be fine. But again, that's low battery, and we tested this and validated it and made sure that the patients that got to this point were able to function okay, and it worked out just fine. Dead battery mode. So when the battery on the Kinects goes dead, it is an open default system. So the valve that I showed you a picture of or an example of, it stays open. You cannot close it, and so essentially there's limited mode, and it didn't feel unsafe. It just felt uncomfortable. So I would say if you get to a point where the battery dies, you need to charge it, but it's not unsafe. "30 degrees range of motion." The reason why you'd want to maybe do the manual lock would be for putting on a pair of pants. You can lock it out and you can pull the pants on, with the foot plantar flex. It'd be easier, getting the pants over the foot. You could also is to lock it out. It's not a powered ankle. It's not going to accelerate the gas pedal, but I would definitely lock it. You could use it for, if you're going up a ladder, you just want it to be locked out. There's a lot of different applications for the manual lock. But again, those are the different demonstration modes you can go through with a patient. All right, so this is a video on the manual lock that I will toggle over to my video screen here. And let's see, it's 2:53. We probably got 15 minutes left here. Stay with me. All right, so here's the manual lock. I'll be muted again. Okay, should be back on again. That's about the that I forgot to mention about the. One second. There we go. Okay, so a couple of things about the last video is the and I forgot to mention the manual lock. You can engage either on the app or the keypad, and you probably, if you double click the center button on the keypad, it locks the ankle as well. All right, so I mentioned before about the cadence report. So this could be a value to document. If you're doing a trial with a Kinnex, which we can do for you. Let's say you let the patient use it for a couple of weeks, and if you're trying to prove that the patient can walk with variable cadence, and they're a K3 ambulator and they're a candidate for the technology, it stores 2 weeks of usage, and it basically shows the number of steps they took at a slow speed, a normal speed, and a fast. So how many steps they take per minute is based on is the basis for the different slow, normal, and fast categories, and then it shows you how many steps they took. So you could use that as a document for insurance approval, possibly. Print, or it's a PDF version for documentation, so you can scan it as well. All right, so the status screen. Haven't shown you guys this yet, but as you go from, we've gone through basically the setup. You can disconnect from the ankle. We've gone through the tools, and now we're at the status screen, but it shows you a lot of good information. It shows the serial number of the ankle. It shows you the battery charge. So again, that patient can look either they can press a battery button on the keypad, and it kind of tells them based on the color and if it flashes where the level is. But if you want the exact percentage, you can look on your app. It shows you the total number of steps. So the patient might have fun with this, kind of seeing how many steps they've taken. It's like an odometer. So it doesn't show their daily step count. It shows the life of the Kinnex. You guys can use it for documentation purposes. You can document if they came in today, they had 61,499 steps. You can check it in like a month from now. You can check your firmware versions as well. So the Kinnex app. So again, this is for the patient. Again, Gait Lab is for the clinician. Kinnex app is for the patient. And again, they can just Google or go in the App Store and look up Freedom Kinnex, and it'll pull it up. And so basically, it's a stripped down version of the Gait Lab app. But so one cool thing is you can change your shoes either on the keypad. So the center button, which is the manual lock button that you press twice to engage the manual lock, you can also press and hold it. I have some patients that prefer that method. In addition to that, they can use the app, and they can actually store 100 different pairs of shoes. And so if they have, obviously which is super duper handy. If they had their Vans on and then they're going to they want to go barefoot in the house, and they just click on their barefoot setting, and it's going to go to that calibration of that particular setting. And then their status screen is pretty similar to the Gait Lab. It's going to show settings, or most of the settings within the Gait Lab. I will say that the first time, so whatever we set that as a clinician, when they go on to their app, it's going to show all 0. Or down 10 from where you set it. So let's say we left it at 80. So they can go up to 90 or down to 70. So if the ankle we left at 65, which is factory default, they can go up to 75 or down to 55. So they have 20% adjustability up and down. And then on the toe, they actually have full adjustability on the toe, because we just felt like that it's only 3 degrees either direction. They really can't mess up a whole lot. And then all 3 of these settings, they actually can fine tune it per shoe. So let's say they have a cowboy boot or something with a high heel that has a really firm, hard heel. That may have a different heel setting than like a sneaker. So they can fine tune these settings per shoe as well. So it's pretty customizable. And then their tool screen, so again, they have the manual lock. They can obviously disconnect, and they have to also pair and unpair, or pair and disconnect from the ankle when needed. A couple other slides here. So so we do have something. It's the freedomkinect.com website that you guys can access. And what it is, it's a digital platform or support platform that really is dedicated to Kinects and dedicated to showing you guys or making videos available to you guys. It has user testimonials, it has clinician training videos, it has patient training videos. So I would definitely check it out if you guys have not used it, or to check out what's new. But you know, again, this is for you guys and your patients. All right, so wrapping this thing up. So we're right at an hour. So design for real life, again, you know, the goal was to make something that really focused on ADLs and help patients with, you know, sitting, relaxed mode, going up steps, going down slopes, that kind of thing. You can see Ramin here is utilizing the range of motion of the ankle, and he's around the water, obviously. So again, it's IP67, but 30 degrees of range of motion. Manual lock that we talked about, again, you can engage in any position within the 30 degrees. And the dynamic lock is referring to the standing lock as long as you've met that dorsiflexion stop angle and you have that 20% load. So that dynamic lock happens during standing and also walking. And then we talked about the two different apps. So again, if you forget and you're trying to connect to the ankle using the Kinect app, which admittedly I've done before, and you've got the Bluetooth antenna on, you can't connect with the Kinect app. You have to turn it off to use the Kinect app. You have to turn it on. That's a high energy Bluetooth for the Gait Lab app. So just make sure you have these two things straight. Again, 0 to 2 inch heel height adjustments. And then again, IP67 rated. A couple other things I'll say is we have regional prosthetists that are available for you guys. Myself, I'm kind of the Southeast specialist, and Haley's out west, and Jeff Culette's in the Northeast, and then we have Sarah Stillies that are help desk. So we've got this team of people that are here to help you guys, you know, through, you know, hopefully when we get back to some normalcy, but through these times where you guys are trying to fit devices, and we're in a position we're not totally grounded, but we're not traveling like we used to, but we can do a lot over, you know, the phone, FaceTime, Skype. We have this app called a rescue app where you can actually see your phone screen. So we can do a lot to help you, you know, through these different fittings if you need us. So time for questions. Sarah, or not Sarah, but Haley, do we have any, first of all?
You do. You have 3 questions here, and everyone let me know if there's any others. Again, please use the question system down in the bottom. I'm trying to respond to people as they're raising their hands as well.
Okay.
So first off is the weight limit. Is the 275-pound limit, is that dependent on foot size, or can all sizes go that high?
All sizes.
Okay. Can you please also address battery life?
So battery life, what's the document? Is it 36 hours, Haley?
Sorry, I'm trying to send somebody a chat here. So typically for your average patient, they're going to get at least a full day out of it, plus a little bit more. I believe the one we have heard the longest is right about 30 hours.
Yeah, and I just always use a comparison, because if you say something like it's 36 hours or whatever it is, it's kind of like a cell phone to me. If the patient is walking a ton, then, you know, if they're going to Disney World and they're walking 20,000 steps, then, you know, maybe a little over a day, and then they need to charge it. You know, if somebody is more sedentary, it's probably gonna last 3 days, just like if you're on your phone a lot. So we just tell people, and it doesn't seem to be a problem, we tell people to charge it nightly. That's the bottom line. Okay.
And then last question, unless another one rolls in, is can you address, oh, here we go. We got stuff coming in. All right, hang on. So let me start here. Is this an internal battery or removable battery like Plie?
It is an internal battery. So my knowledge of why this is the the power required to power this system has to be an internal battery that's bigger than what the plie camera battery size is. So it's all internal.
Okay. And then we have a couple questions around the water submersibility, specifically salt water, if there's anything they have to do in order to make it IP67, and water in the foot shell.
So nothing you have to do to make it IP67. That IP67 rating is not a Freedom thing. It's just an international protection rating for electronics. It actually says, what it says specifically is 30 minutes, 1 meter, occasional submersion in fresh water. What we tell people is kind of like we do with plie. I mean, if you're going to go in or around salt water, you just have to make sure you rinse it quickly and rinse it well. You know, from a foot shell standpoint, you know, everybody's got their own tricks. I mean, there's no holes currently drilled in the foot shell. I mean, if somebody wants to do something like that a lot, then I would maybe, you know, put some holes in the foot shell for drainage. But really nothing that you need to do to prepare it. I would say if somebody is routinely in and around water, maybe have them come see you periodically just to maintain it and to, you know, change out the SpectraShock and just clean out the inside of the foot shell.
Yeah, the only thing I would add on that is that if you're concerned about, you know, making it IP67, please make sure the battery cap is in place. That is the one point that water could start to enter the system. So please keep that in mind.
That's a good point, yeah.
Let's see, service intervals.
There are none. The only thing you have to do is there's some firmware updates that you can check once you connect to the ankle, and that's done remotely. I would say that there's probably occasionally going to be some app updates, I'm guessing possibly, but you don't have to send it in. If you do have to send it in for repair, it's similar. The program's going to be similar to, actually, I can't remember what we decided from a loaner standpoint. Do you recall, Haley?
I'll be honest, we have not come across that issue yet. So we have, I believe, correct me if I'm wrong, Eric, but I believe it's about 125 in the field since February, or I'm sorry, no, we launched in February. 125 in the field for over 6 months, and I do not believe we've had one come back yet that we have had to deal with that. So I do know that we are planning on some form of loaner pool should it have to come in, but has not been an issue yet.
I mean, the reason why it's a little bit more of a challenge is because the ankles are all the same, but the foot plate and categories are going to be different. It's not as simple as a plie. So, but certainly, go ahead.
Hey, Matt, this is Jeremy. I'm just going to address I mean, we have not had an issue at all, and loaners will be made available. I mean, just like with the plies, we are, you know, we'd like to consider ourselves an easy to do business with company, and so we definitely are going to continue to be that way. So I don't see there being any issue at all.
Okay.
And then I believe we have one more question, which is just basically, if somebody has a mechanical issue, are there any vibrations or audible noises or anything like that that they would know about?
The only thing I'm aware of is just error codes on the keypad. And that's something we could probably diagnose remotely. Like if you were seeing a patient and there was flashing, we potentially could understand what those error codes are and possibly reset the ankle. But I've not had that happen yet. But as far as mechanical, there used to be on Kinnex 1.0, there would be an error message on the app. So there are things that happen, but it's not something you can typically diagnose on your own. You'd have to reach out to us.
All right, and that I believe are all the questions. Let me scan through here real quick. Sorry, I'm trying to check off the ones that have been answered. I believe that's it. I think we're good. Okay,
so we'll just finish up. Haley was just mentioning again the upcoming webinars. So the next one on April 2nd, same time as Eric mentioned, every single week for the next 3 weeks. So on April 2nd, Haley, who's on the call right now speaking, will be doing hydraulic ankles, which is Conterra and control. And then on a week later will be a microprocessor knee overview with Jeff Culette, who's in the Northeast. And then the last scheduled webinar is IQ vacuum system with Sarah Stilley. Again, that's on April 16th. That's all I have. We finished at 1 hour and 10 minutes. Pretty good for 1.25 CEUs. Anybody else? Jeremy, Eric, Haley?
Hey, Matthew, I'm good. I just really want to thank everybody for taking the time to join us today. My name is Jeremy Matthews. I'm the head of sales and marketing for Freedom in the U.S. And we just really appreciate everything you're doing in the field to take care of our amputees. And we're here to support you guys. So during these tough times, we're just trying to keep engaged, like Eric said. And I want to thank Matthew and Haley for what they did to get this thing going. They went through some serious practices with me to pull this off. So you guys did a great job. And again, thank everybody for taking the time out of their day today.
Thanks, guys. Appreciate it. I'm signing off.